Alright, buckle up, because this is gonna blow your mind. We're diving headfirst into the captivating world of machine learning. Get ready for an exhilarating journey where we unravel the mysteries behind intelligent systems and predictive algorithms. Prepare to have your perception of technology transformed as we explore the very essence of how machines learn and adapt. This isn't just about understanding code, it's about grasping the fundamental principles that are reshaping our world. We're going to break down every machine learning algorithm, demystifying the complex processes that power everything from your personalized recommendations to cutting-edge medical diagnoses. We'll explore the inner workings of these algorithms, revealing how they analyze data, identify patterns, and make informed decisions. Forget the jargon and technical complexities. We're here to make machine learning accessible to everyone. And the best part? We're doing it with zero maths headaches. That's right, no complicated equations or confusing formulas. We'll focus on the core concepts and intuitive explanations, ensuring that you grasp the essence of each algorithm without getting bogged down in mathematical details. Our goal is to empower you with a practical understanding of machine learning, regardless of your mathematical background. Whether you're a curious newbie taking your first steps into the world of AI, or a seasoned code wizard looking to expand your knowledge, this crash course is designed for you. We welcome learners of all levels, from those with no prior experience to experienced programmers seeking a refresher. Our aim is to create an inclusive learning environment where everyone can thrive and unlock the potential of machine learning. So, let's make ML simple. We're going to strip away the complexity and present machine learning in a clear, concise, and engaging manner. Get ready for lightbulb moments as we unravel the intricacies of these powerful algorithms. Our focus is on providing you with a solid foundation in machine learning, empowering you to apply these concepts to real-world problems and innovate in exciting new ways. Right, let's speedrun the brainpower behind your favorite apps. We're going to embark on a rapid-fire exploration of the algorithms that power the technology you use every day. From the apps on your smartphone to the websites you browse, machine learning is working behind the scenes to enhance your experience. Get ready to unlock the secrets of these intelligent systems and gain a deeper appreciation for the power of AI. We'll uncover the hidden intelligence behind your favorite apps. Think about the apps you use daily, the ones that seem to anticipate your needs, offer personalized recommendations, and adapt to your preferences. These apps are powered by machine learning algorithms that are constantly learning and improving. We'll explore how these algorithms work, revealing the magic behind the seamless and intuitive experiences you've come to expect. First up, linear regression. This is the foundational algorithm that forms the basis for many other machine learning techniques. It's a simple yet powerful tool for understanding relationships between variables and making predictions based on data. We'll explore the core principles of linear regression, revealing how it works and why it's so widely used in various fields. It's like drawing the best straight line. Imagine you have a scatter plot of data points, and your goal is to find the line that best represents the overall trend. That's essentially what linear regression does. It finds the line that minimizes the distance between the data points and the line itself, allowing you to make predictions based on the relationship between the variables. Through your data, finding the pattern that underlies the seemingly random distribution of points. Linear regression helps us to extract meaningful insights from data, allowing us to understand the relationships between different variables and make informed predictions about future outcomes. It's a fundamental tool for data analysis and decision-making, so you can predict things like future trends, potential outcomes, and expected values. Linear regression allows us to extrapolate from existing data to make informed guesses about what might happen in the future. It's a powerful tool for forecasting and planning, enabling us to make better decisions based on data-driven insights, like house prices based on size. The bigger the house, the higher the price. That's a simple, linear relationship that linear regression can model, but it can also handle more complex scenarios with multiple variables, allowing you to predict house prices based on factors like location, number of bedrooms, and square footage. It's a versatile tool for real estate analysis and investment decision-making. Next, classification algorithms, which are all about sorting and categorizing data into different groups. These algorithms are used to identify patterns and assign data points to specific classes based on their characteristics. From spam detection to image recognition, classification algorithms are essential for a wide range of applications, like logistic regression and decision trees. Logistic regression is a statistical method for predicting the probability of a binary outcome, while decision trees use a branching structure to classify data based on a series of decisions. Both of these algorithms are powerful tools for classification, each with its own strengths and weaknesses. Imagine being a bouncer, deciding if someone is cool enough, dressed appropriately, and generally fits the vibe of the club. Your job is to assess each person and make a decision about whether or not they should be allowed inside. This is analogous to how classification algorithms work. Gets into the club based on their outfit and attitude. You're using certain criteria to classify people into two groups, allowed in or not allowed in. Similarly, classification algorithms use data to classify data points into different categories based on their features. That's classification. It's all about assigning data points to the correct category based on their characteristics. Whether it's identifying spam emails, diagnosing medical conditions, or recognizing objects in images, classification algorithms are essential for making sense of the world around us. K, nearest neighbors? This algorithm is based on the principle that similar data points tend to be located near each other. It classifies a new data point based on the majority class of its nearest neighbors. It's a simple yet effective algorithm for classification and regression. It's like asking your mates what they do. When you're faced with a difficult decision, you consult your friends, gather their opinions, and then make a decision based on their collective wisdom. K-nearest neighbors works in a similar way, using the opinions of its nearest neighbors to classify new data points. And going with the crowd. If most of your friends would choose option A, you're more likely to choose option A as well. Nearest neighbors follows the same principle, classifying a new data point based on the majority class of its nearest neighbors. It's a simple yet powerful algorithm for making decisions based on the wisdom of the crowd. Support vector machines are powerful algorithms for classification and regression. They work by finding the optimal hyperplane that separates data points into different categories. SVMs are particularly effective when dealing with high-dimensional data and complex decision boundaries. Draw the absolute clearest line between categories. The goal of an SVM is to find the hyperplane that maximizes the margin between the different categories. This ensures that the decision boundary is as clear and robust as possible, minimizing the risk of misclassification. Think of it as splitting two rival teams on a sports field. You want to draw a line that clearly separates the two teams, ensuring that there's no ambiguity about which side each player belongs to. Support vector machines do the same thing, but with data points instead of sports teams, with the widest possible gap. The wider the gap, the more confident you can be that the line is correctly separating the two teams. Support vector machines aim to maximize this gap, creating a clear and robust decision boundary that minimizes the risk of misclassification. Now, neural networks, the rock stars. These are the algorithms that are driving the AI revolution, powering everything from self-driving cars to virtual assistants. Neural networks are inspired by the structure and function of the human brain, and they are capable of learning complex patterns and making highly accurate predictions. They mimic your brain with interconnected nodes that process information and transmit signals to each other. These nodes or neurons are organized in layers, and the connections between them are weighted to reflect the strength of the relationship between the nodes, connecting info in layers, allowing the network to learn hierarchical representations of data. The first layers might learn simple features, while the later layers learn more complex and abstract concepts. This layered structure allows neural networks to extract meaningful insights from raw data, to spot patterns no human could catch. Neural networks can analyze vast amounts of data and identify subtle patterns that would be impossible for humans to detect. This makes them incredibly powerful tools for a wide range of applications, from fraud detection to medical diagnosis. Clustering with algorithms like K-means is all about grouping similar data points together. These algorithms are used to identify natural clusters in data without any prior knowledge of the categories. Clustering is a powerful tool for exploratory data analysis and pattern discovery. is sorting your sock drawer by color, grouping together all the red socks, all the blue socks, and so on. Clustering algorithms do the same thing, but with data points instead of socks. They identify groups of data points that are similar to each other and assign them to the same cluster. No labels needed, just finding groups. Clustering is an unsupervised learning technique, which means that it doesn't require any prior knowledge of the categories. The algorithm automatically identifies the natural clusters in the data without any human intervention. Random forests? This is an ensemble learning method that combines multiple decision trees to make more accurate predictions. Random forests are known for their robustness and ability to handle complex datasets. They are widely used in a variety of applications, from image recognition to financial modeling. Imagine asking 100 decision trees for advice on a complex problem. Each tree would analyze the data from a different perspective and offer its own recommendation. Random forests combine the recommendations of all the trees to arrive at a final decision, and trusting the majority. The final decision is based on the majority vote of all the trees in the forest. This helps to reduce the risk of overfitting and improve the overall accuracy of the model. Random forests are a powerful and versatile tool for machine learning. And finally, ensemble methods are techniques that combine multiple machine learning models to create a more powerful and accurate model. Ensemble methods can improve the performance of individual models by reducing variance and bias. They are widely used in a variety of applications, from fraud detection to medical diagnosis, combining weak algorithms to make a super strong one. Just like a team of superheroes, each with their own unique abilities, ensemble methods combine multiple weak learners to create a strong learner that is more robust and accurate than any individual model. Like a superhero team-up, but for data. Each algorithm brings its own strengths to the table, and by working together, they can achieve results that would be impossible for any single algorithm to achieve on its own. Ensemble methods are a powerful tool for improving the performance of machine learning models. Machine learning isn't magic. It's not some mystical force that can solve all your problems. It's a powerful tool, but it's important to understand its limitations and use it responsibly. Machine learning is based on solid mathematical principles and requires careful planning and execution. It's clever maths, teamwork, and a dash of common sense. Machine learning requires a solid understanding of mathematical concepts, as well as the ability to work collaboratively with others. And of course, a healthy dose of common sense is essential for interpreting the results and making informed decisions. Smash that, like if you learned something, and let us know in the comments which algorithm you found most fascinating. Your feedback helps us create more content that you'll love. We're always striving to improve our videos and make machine learning accessible to everyone. And check the full video for a deeper dive. We've only scratched the surface of the vast world of machine learning in this crash course. The full video provides a more detailed explanation of each algorithm, as well as practical examples and code demonstrations. So, if you're ready to take your machine learning skills to the next level, be sure to check it out.